I want to introduce the next speaker. The next speaker is me. Hey, look at that. So I get to talk. So well, I'm going to talk about a little project we did here at PMG. We've called it the Impossible Intern. We'll talk about why we called it that. But the subtitle here is what happens when Gemini Prefect, Graph of Thoughts, and Artisans collide. We heard Sachin talk a little bit about chain of thought. Graph of thought is kind of in that space as well, right? So who am I? I'm Brent. I'm the director of AI here at PMG. My email address really is bs@pmg. And if you want to reach out and ask me about either this talk or anything PMG related, it's pretty easy to get to me now. I have a longer email address, but this is the easy one to remember, so it's the one I show you all. So about 6 months or so ago, Google asked PMG to leverage LLMs to create an impossible ad, right? We wanted to, and they wanted it presented at this conference called Cannes Lions, and that's like in Cannes, France, and it's like where all the fancy people go. I will never get invited to go there, but you know, we were asked to invite. Google wanted to throw out this challenge to us to see if we could do something. PMG answered the call. Our president stood up on stage, presented an idea, a creative idea, and it actually got a lot of it was well received, I guess is what I want to say. A lot of interest. The client was like really fascinated by it. It was really, really cool, and it was really, really awesome. The Impossible Intern was what we did not show. The Impossible Intern was the second place thing that we wanted to present, but we kept on moving it forward and going with it. The very first sketch that we did for the Impossible Intern was basically this. PMG, in addition to doing digital marketing, we have a creative agency in-house. And so we will build creative content for a lot of our brands, right? Well, I don't even know which ones they are. I know which ones they aren't, but point being is, we wanted to build a tool using LLMs that would help people generate creative content. That seemed like a pretty good approach to do it. So what we tried to do is we came up with this idea where, what if we had a bunch of ideas that are just from anywhere, doesn't really matter, and we have this thing called a creative brief. The creative brief is like the campaign guidelines or the brand guidelines, like, the Nike swoosh has to look like this and it has to be present here and you can't put it over here, those sorts of things. Could we mix the creative brief with these ideas and score them, score the ideas according to the brief to see how well they did, then turn around and rank them up, right, according to some prompt that we have, and then generate some content based on another prompt that we have, and then send it off to a human being for further refinement, and eventually win the Palme d'Or at Cannes. And then down on the bottom here, we can kind of consider that, we've got more than just the creative brief. We've got all this other data that we can feed into our prompting strategy, right? We've got thousands of audience members. We've got millions of performance click-through rates and KPIs, and terabytes of actual content of images or videos that we can all mix into this. So we wanted to see if we could come up with a framework in order to make this sort of thing happen. And this is the story of that framework. To kind of, that was conceptual. This is actually you can't read this. You're not supposed to read this, so don't worry about it. This is an execution graph of us actually executing the process on the prior page, and this was generated through Prefect, and I'll talk about Prefect here in a little bit. If you don't know what it is, don't worry, I'll introduce it. But basically, it's real. It happens. It can do stuff. And we can actually use open telemetry to capture metrics around talking to the LLMs and go through things like Datadog or normal engineering tooling in order to capture the information around it. Like, hey, in order to do one of these things, it costs 26 cents to do it, right? So that's probably a lot cheaper than hiring an artist to do it. but we'll talk about that too. And then there's other things in here. The point being is it was as much of an engineering challenge as it was an LLM challenge or a creative challenge. So one of the key things in there was graph of thought prompting. And I'm highlighting prompting here because there is a graph of thought architectures that are out there. And those are like mixing together transformers and encoders and decoders in different ways, or they can even drill down into hardware. And we can talk about, what NVIDIA is doing or something along those lines. Here's a challenge. I will come to a talk that talks about graph of thought architecture. So somebody in the audience, please put it together and I'll be there and listen to it, maybe in January, who knows, right? But that's not this talk, it's prompting. This is one of the seminal papers on graph of thoughts. About a year ago, if we remember what we were all doing, we were just doing simple input-output prompting, right? Where we just have a single shot, one shot, maybe few shot type of prompts where we would just ask an LLM a question, we get an answer back, and that's it, input to output. Some people thought down, and Sachin kind of talked about this a little bit in his closing, he thought about, if we have an input and we break it up, we kind of decompose it a little bit into smaller pieces, we can linearly interrogate the LLM for more information and enhance and develop the response over time, right? So then the next one was multiple chains of thoughts. Let's just run the same sort of thing through multiple prompts, maybe a little bit different. And then at the end, we somehow magically choose a correct answer. Eventually, we got to tree of thoughts where we have got branching coming out of each of these thoughts, and it's kind of walking down the chain here, but it's definitely, it's a waterfall, right? Everything just kind of flows down. At the end, we've got graph of thoughts, and this is kind of where we're at now, is that the input can come in and we can decompose the input into multiple different responses. We can like refine things in a loop here. We can backtrace, we can delete nodes as we go along, and eventually the whole thing cascades down to an output. This is not exactly a directed acyclic graph, but it's not exactly a freeform graph either, right? We don't see any loops that come from we don't see any loops that go from one node to another node, right? They're all kind of self-contained. So if there's a network theorist in the house, I would love to know what to call this kind of restricted graph, because I don't know, because it's not a DAG and it's not just a directed graph either. Well, I guess it is a directed graph, but it's not fully cyclic either. So, but the key, one of the key, well, this is the GitHub repo for it. And of course, there's a link off to the archive table because everybody's got an archive paper these days. I don't know why, but they all do. But this was the key thing that we wanted to leverage in this thing. One of the key insights for this is that LLMs will provide better responses when a prompt is mostly atomic, right? It does one single logical thing. That's it. Don't ask it to, you can feed it as much context as you possibly can, but only ask it to do one thing at a time, and then go on to the next prompt, and then go on to the next prompt. The outputs of prompts are inputs to other prompts, right? So we build it up as we go. The rubric I use here is like, when I write a prompt that says do X and then do Y, that's probably two thoughts, right? And that's probably a good signal for me to split this up into two different tasks, two different thoughts to go with. Gemini, what's Gemini? It's an LLM. You probably haven't heard of it. Actually, you probably have. It's Google's response to the LLM explosion, and it's from Google. It works pretty well. Google asked us to do this, so we were going to use Gemini, but from a corporate perspective where we care about money, there's actually an economic reason to maybe consider something other than ChatGPT. There's this website here, this slide's a couple months old, but this website here, artificialanalysis.ai, which I think is a great term, basically comes up with these charts, and it's a price per quality curve, right? And you can see out here for 1 million tokens, Claude 3 and GPT-4 are pretty expensive, $35-40 each, but they perform pretty well, right? You've got back here GPT-4o, it's less than $10, performs extremely well. Down here is Gemini 1.5 Flash and Gemini 1.5 Pro. They're not quite as high quality, but they're half the price. And maybe that's good enough. Maybe it's not, maybe it's good enough, but it is an economic consideration one can use when they're considering hosted LLMs. And I say hosted because, you know, you can spin up an AWS image, throw a GPU at it and spend as much money you want to by yourself, or you can go off and buy some, you know, Mondo NVIDIA box and, you know, spend $1 million on that and amortize the cost out of over anything. But this is it's a consideration that one should probably think about. The good news is if we went and looked at this thing today, it would look kind of the same, except for all of these things we've pushed up and to the left. What this means is everything's getting cheaper and everything's getting smarter, right? There's this concept of called an efficient frontier, which is this, which is kind of a constant curve that it's just getting better for, you know, the mere mortals in the world, you know, folks like us, which is fantastic. Gemini knows this, or Google Cloud, they know this. And the thing is what Google does, and I'm not here shilling for Google, don't get me wrong. It makes it really easy to use our content, our PDFs, our images, our videos, our things in BigQuery and everything, right, inside of the LLMs, right? We can just inside of Google Cloud use it all. We don't have to hop here, hop there, hop over everywhere else and stuff like that. What I like about that is that our content, our data helps to build our moat, right? PMG only has, you know, PMG, anybody can prompt, but only PMG can bring PMG data in there. Anybody can prompt, but only Brent can bring Brent data in there, or Vilma's data. Vilma's the only one who has that. So, you know, she can build her own moat. And that is kind of important when we're thinking in terms of competition and, frankly, capitalism. All right, so I'm going to do a little demo of what this thing looked like, if I can figure out how to get over here. Can you all see this? Sure you can. Fantastic. I'm not a UX designer. Just going to say that right now. And basically this is Streamlit and it's trivial, right? What I'm going to do here is I'm going to go out, I'm going to grab our best Western. Oops, you guys can't see this. That's okay. I'm going to grab our brief. It's called Life's a Trip. It's our campaign brief. And I'm just going to ask the system to generate a scoring prompt for it, right? This is a PDF that basically says, hey, for this Life's a Trip campaign, here are the brand images that we want you to use. Here's the look and feel we want you to use. Maybe here's the target audience that we want you to use, et cetera, et cetera, et cetera. And so now Gemini is going off and parsing this thing and coming back with this prompt. It extracts the main theme. It extracts, you know, different categories for sub themes, right? A target audience, the brand, visual style, warm and inclusive, messaging, life's a trip, make the most of it, et cetera, et cetera, et cetera, right? And it basically just parses this all in here. And now what I will do is turn this thing into a prompt for scoring unseen assets against this, right? So we can just take some random asset, random ad off of the interweb or from our creative people and score it and get an idea of how well that adheres to the brief. And so that's the next stage. And so we've got this prompt here that was generated. It's very specific. It's very JSON-y. And I did that because I need to chain things along, but it works. I'm going to browse some files. I'm going to pick up, I'm going to set this down. Hold on. I've got 5 files up here. I'm going to score them each, and we're just going to get the scores back, and I'll show you what those scores look like. So now Gemini is going out, or the intern is going out asking Gemini to score each of these bad boys, and then we're going to use these scores down the road to consume an external prompt and then generate a asset that is based on our prompt, but then also based on what it thinks from the brief and also what it thinks from all of these assets here, right? So it's kind of mixing all of this data together. So the data that I just loaded up, Life's a Trip, Wreck Hikers, this PNG file. Those are maybe, we can consider those as ideas that our creative team is generating somehow. So like this first one here, Best Western Family Beach Vacation, it's parsed across, it's cracked open the image and it's looked in there. It scores it at 0.8 with subcategories, family and friends 0.9, 0.6, visual style is a 0.8, and then that's the image that it scored, right? That's my kid right there. Here's a group of friends in Ireland that got scored as a 0.5. It doesn't really do a good job. This image doesn't do a good job against the creative brief, so it's scored it pretty low, even though, it's a fine photo, right? It's a fine photo. This one here, a concrete wall. It's a photo of a concrete wall with a man standing in front of it. Scores a -1. Because it's actually nothing to do with the brief. I'm going to go ahead and pause this one so you can all take a photo of the photo and try to figure out exactly what I'm referencing here in this photo. And there you go. There you go. Does anybody know where this is? Has anybody actually been to this? I mean, obviously I have, but there it is, et cetera, right? So we've gone through and we've scored all of these things. And now after we've scored all these things, we can ideate an asset. And the asset would be a realistic wide angle photo of a family arriving at a lodge, blah, 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 blah. We're going to click on this. And now based on what we had and what we've got, we are going to augment the prompt with positive and negative keywords and go off and generate the new asset, right? The brand new asset. And, this one here, this is what it looks like. There's my woman wearing a jacket that looks like a ferocious bear. And they're all arriving there. And this is that. Yes, we've got a question. Which image generation model am I using? This is Google's Image Gen 3, which they just released general availability about a month ago. First time we were doing this, we were Image Gen 2, and I was like crying because it just was awful. But this one's not awful. Anyway, then this thing here goes through and we score it, and we get a 0.8 and a 0.9 and a 0.7, and the scoring all happens and stuff like that. So all of these scores we can now persist and use in a database for maybe the next rev that we go through and stuff like that. And now we're starting to build up content and moving forward from there. So that's the demo. We'll go back to the presentation. Yeah, so basically summarizing the brief and generating the prompt. We saw this, we see this summarized brief thought. It takes in the asset and a prompt, gets this thing back, feeds it into here. This next thing here is the generated scoring prompt, gets generated from this thought, and then this thought comes out and gets fed into the scoring asset thought score asset thought that comes out, and we get an asset back from there. So that's kind of how things are chaining together very programmatically. And kind of pay attention, kind of remember summarized brief thought and the names of these functions as we go. The summarized brief thought, what does it look like? It's trivial, right? Basically, ignore this task decorator for a little bit, this annotation for a little bit, but go out to the model, generate content based on the asset, which in this case is the brief, and then the prompt. Set some safety limits because it's Google and they're going to be picky about those sorts of things. Come back with the brief and then just respond with that summarized brief. And we saw that in the thing, and that's kind of how that one thought gets executed, right? It just does one thing. The prompt is kind of a little bit more involved, right? And I just want to highlight this part. We have to supplicate ourselves to the LLMs. You are a very smart advertising executive and an expert at summarizing creative briefs, whatever that means. Summarize the attached brief that can be used to both generate new ideas and to evaluate the quality of ideas, right? So I broke my own rubric. It's doing two things in one prompt. That's probably a problem. I'm gonna have to break that up. Blah, 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 a lot of stuff, a lot of context to put into there. Then we've got this generate scoring prompt, right? So I'm gonna use this prompt to generate a scoring prompt, and this one's a little bit more detailed, and it does the only do valid JSON and all that stuff, which always fails. I don't know if anybody's ever successfully done that 100 times in a row. And then what kind of JSON am I going to generate? I used Pydantic to model the scores and the assets, right? And so the bottom class there is just an asset. It's got the title, the description, a main score, which is a type score, and then a category scores, which is a list of other scores. And then the scores basically just have, a description of the score, the criteria, why it scores this way or the other way, a value, which is basically from -1 to 1, and then, a rationale. Why did it score this way or that way? So that we've got this content, we're building up a content library at this point. All that gets thrown into this quick little thing here, right? We take the creative brief, the summarized brief prompt, we throw it through Gemini, we get the summarized brief at the bottom part. We get the JSON example and the JSON schema for the scoring prompts. We generate the scoring prompt. We throw both of these two things into Gemini, and we get the generated scoring prompt on the back end. Oh, okay, so that's that. Where does the what? Where's the target seeing it? What's the target in this context? I'm sorry, I don't quite understand I use asset, right, which is basically just the image, right, or the video. Well, so we generated that at the very end. Not yet, but that is definitely a use case, right? We could generate a bunch of assets, feed them back into the system, generate more assets, and refine as we go. No, I didn't. I did not say that. What I said is that we took a bunch of existing assets that were out there, right? That were just out there for whatever reason. They could have come through a generative AI system, or they could have been existing images like on the column here, right? They could have done that. We score them, we rank them, we extract some content from them, and then we generate the final asset, which is what you saw with that woman wearing that jacket. That was the generated thing. No. Well, no, we haven't done, if I can phrase your question, maybe we did not take that final image of the woman and put it out there in production and yet. And we'll get to why not in a second, right? But basically these on the front end, on the left hand side here, could have all been existing creative copy. They could have already been out in the real world, and in the real world we could have connected in performance data down at the bottom, KPIs and all that kind of stuff. So this was built to be kind of a framework in which we can leverage off of. No, this doesn't do that yet, right? But what you're asking is certainly 2025 plans. Yeah. Doop, 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 doop. Okay, and so the generated scoring prompt, this is what it looks like. I'm not going to let you guys read it, but you can see this is basically a JSON document that we've generated through giving it a bunch of other data, right? And so we're using prompts to consume data, to generate other prompts, to generate a final prompt, et cetera, right? And so, I heard you like prompting, so we made a prompt to generate prompts, and you can prompt when you are prompting, right? And then finally, Prefect. What is Prefect? Prefect is a workflow orchestration framework for building resilient data pipelines in Python. If you've ever used Airflow or Dagster or something like that, Prefect is very similar to those things, right? I used Prefect for weird historical reasons, but it works fine. They claim it's the easiest way to transform any Python function into a unit of work. And, I'm not going to argue with that part. Prefect encourages small tasks. Each one should represent a single logical step of your workflow. That sounds kind of familiar with the graph of prompt things that we were talking about. And this allows Prefect to better contain task failures. I bolded the task failure part here because I'm foreshadowing what's coming up next or in the future and stuff like that. And then it talks a little bit more about Prefect. I was going to demo Prefect, but for the interest of time, the boring demo is just a command line run. The more engaging demo takes way too much time, so I'm not going to do that. But what we can see here is the main flow of the intern inside of Prefect. We get a summarized brief back. We've seen that before, right? But we also get summarized brief thought dot submit. I'm not calling the function directly. I'm passing it through this submit thing, right? And then here we get another submit. And then here we get this map function, right? If you're a Python person or even any sort of multi-process, multi-threaded, asynchronous type of person, these concepts probably sound kind of familiar to you. And even here we've got futures and stuff like that, right? And that's the way you think about it with Prefect, and it's pretty neat, right? We've got these Prefect idioms, map and submit. These schedule the task to the Prefect workflow engine. It doesn't have to be completely scheduled up front like in the web app. We can let the Prefect workflow engine figure out what to do next and how to do things next. And then a future is kind of the promise that Prefect will eventually give you this data. So you can still program around it, but we've got... Yes, what Prefect does, so, and we'll get, I'm going to hold that question. The question was, is Prefect defining the workflow? I'm going to hold that question for another slide or two, and then we'll get right back to it, right? These are asynchronous semantics, kind of like Dask or async IO. If you're a Python programmer, you've done it. If you're a Java programmer, you've done it. If you're a PHP programmer, I assume you've done it. I don't know. And et cetera, right? But basically, Prefect allows you to focus not so much on the calling, just the logic and the chaining of things together, and it will figure out what it can parallelize or not as it goes. So here is the way to turn score asset thought into a Prefect thing, is you just put the task decorator on it. You have to give it a name. You don't have to tag it. And if you want to, you can define retries and, a retry strategy, a backoff. And the reason why you might want to do that is because down here, I'm validating JSON because I don't trust JSON. And if it does not validate, an exception will be raised, and Prefect will catch that exception and try to do the retry for you. So in case you've got a failure on something that should not fail, or is transiently failure, Prefect can fix it for you, and it'll just execute, and it's pretty amazing. So we're back to this. Right? We wrote a very simple program. It just basically was chaining a bunch of these thoughts together. I gave it some data, and I gave it a bunch of other assets to score. And then Prefect, after loading all this stuff up, Prefect stepped back and said, oh, okay, what's the most efficient way that I can execute this work batch that was given to me in this program? I'm going to zoom in on these things, and we'll talk about them. This top one, get files. This was basically just loading up the starting assets that we started with. The picture of me standing in front of a wall and those other ones. So that can happen. And then the summarized brief thought, that is basically just taking the creative brief and summarizing it into kind of a prompt kind of thing. Prefect recognized that these do not have any dependencies on each other, and so it can execute them in parallel. So it goes ahead and does that. Right? And then at the end of this, we get files coming out, and then we get the summarized brief coming out. And now we're getting a DAG, a directed acyclic graph of dependencies that says out of this summarized brief thought, it goes into the generate scoring prompt thought, right? And it just starts to cascading, and it starts to lay things out as it goes. See kind of what we're doing here? Scroll over a little bit. Here we're scoring an asset, and we get a scored asset response and a scored asset JSON coming out of it. We're scoring another asset, scoring another asset, scoring another asset, another one, and another one. And then down here, we're scoring another one, and here we're scoring another one. You'll notice this one here took a lot longer. Why? X is the time axis. This one here took a lot longer. And if you take a Particular notice, every other scored asset took a response and then a JSON. This one here did a response, another response, and then a JSON. What this bad boy did is when it got the first response, it wasn't valid JSON. It threw the exception, Prefect caught it and just re-executed it and went along. It took me a little bit of extra time to do it, but Prefect was still working, right? It just had to finish this one thought. And then once it gets this one thought, it can go on to the next step. Does everybody kind of see that, what we did here? Hopefully, okay. And then it just kind of cascades down and cascades down and cascades down and continues. And then finally at the end, we generate an image, we score that image, and then we persist the final image, and then that's the image that we kind of saw, right? And so it just works, right? We can now programmatically do this. We can fill a repository of all these generated images, feed it back on itself, run this whole thing on these new images again, and who knows what would happen if we were let it run 1,000 times, right? Would we get final production quality assets at the end? Maybe. We're not. So this is the final generated image. There's a couple of things I want to point out here. A human prompt was this one, realistic wide angle photo, woman wearing a jacket that looks like a ferocious bear, brand logo on the lodge. That's what the human said. This was generated from the brief and some of the negative keywords, right? So the human never said, put the Best Western logo on the lodge, right? The system figured out, oh, Best Western, put a logo, but what logo? We never said that, right? So the point here that we could make is I could take a different creative brief for like Omni Hotels or, the Westin over there, the JW Marriott or whatever, throw that brief at the exact same system. The only thing that changes is the creative brief, and we'd probably get a different logo and a different tagline for this thing as we go forward, right? And so now we didn't build a purpose-built thing for Best Western. We built a platform for any hotel that could do it. Clearly, JW Marriott probably isn't going to do a mountain lodge, right? So we're going to have to do some tweaking there, but it can be a data-driven system to move it forward and make it a little bit more scalable in a business process sense. Final image gets scored pretty well. You can see the scores here. What did we learn when we did this? Okay, parametric prompting, that's pretty cool. We uploaded the brief and that drove everything. We can and should use the large context windows of LLMs to stuff as much of our data into this context as possible. That helps us build the moat. In a conversational sense, that context is the history of the conversation that you're having, but in like PMG sense, it's our database essentially, right? We want to throw as much of that into this as we possibly can, right? We're going to help build the moat. Graph of thoughts is hard. I'm not saying Andrej Karpathy is wrong here. I just don't think he's saying the whole story, right? Yeah, the hottest new programming language probably is English, but I've yet to see an English, a pithy and cogent architecture described solely in English, right? And so this, even though we might be programming in English, we still have to think like software engineers or machine learning engineers and really start to think about how these things kind of get assembled and working in the future, right? Will the hottest new programming language help? Yeah, it will. But I think my guess is that over time, what we're going to wind up doing is coming up with our own Pidgin language, Pidgin English, to talk to LLMs in sort of a hybrid sense, right? As software engineers and as purportedly English speakers. Automating GenAI and GenAI is not all that, right? The final images can be a little underwhelming, right? We're just not ready to go to production with our final images yet, right? Maybe I could do a better job of writing the prompts and architecting the flow, right? Maybe I or all of us could sit down and do a much better job of doing that. But, could we have done it better? It's the LLM that's wrong. That's kind of where I'm at with these things, right? That's kind of where I'm at. Automating GenAI is not all that. What we tested was, can an LLM automatically, yes, prefect, consume upfront data. Yeah, the creative brief, mix it all together through the scoring and all that kind of stuff, and generate a final let's go to market product. No, it can't do that last piece, right? We're not ready for that last piece yet. And that's why we gave it to an intern, right? Because we don't trust the intern to do that. This quote, it's AI until you trust it, then it is automation. I don't trust it yet. I am doing a lot of experiments with agentic design. Thank you, Akshita. Hello, wave. Hi. Yeah, there you go. I attended a talk that she gave on agentic not too long ago, and that's actually starting to me. I'm going to have to delete this slide in not too distant future as I get better at agentic. I don't trust it yet, but if it's not automation, what is it? I think it's augmentation, right? We are augmenting humans, right? I have no idea who Carnage for Life at Mass.2 is, but I thought that this was a pretty good, I don't think it's a tweet, it's something else. There's a big difference between tech as augmentation versus automation. Augmentation benefits workers, while automation benefits capital. I didn't think, you guys probably didn't come here expecting to get, communist propaganda thrown at you, did you? LLMs are controversial because the tech is best at augmentation, but it's being sold by a lot of vendors, including Google, as automation, right? And that's actually a pretty good, I liked this statement. I thought this was a pretty solid statement. It's much more augmentation, right? But we were always here, right? If you remember back to the original sketch, the last slide was give it to a human and let the human refine, get these ideas, get them out, get them in front of our customers, get them in front of our clients, come back with better creative, faster creative, cheaper creative, and then actually go to market with those things. Are there any questions? Yes, sir.
So you're saying it's not automation, it's augmentation, but if you were to estimate, is this saving some of your effort, and how much of, say, a typical workflow of developing these campaigns is it saving you? Like what percentage of the work is it off?
Okay, the question was, how much is this saving us in an augmentation sense, right? And so before this tool, we'd have artists, highly qualified, well-paid artists coming up with creative ideas, getting in front of our clients and saying, hey, what do you think about this? And they're smart people, right? They're not going to give a stick figure or something like that to Nike or something along those lines. These are smart people that are trying to do that. But it's still, we still have to have the artist's time to create that stuff. The one slide that I put up here is to generate that one photo or that one image was 26 cents. And it took, 30 seconds to do it, right? And we can now do that at scale and come up with a bunch of ideas, have those ideas scored by the LLM, filter out all the stuff that we think is not going to go well, and it helps us focus on the ideas that are probably best suited for the creative brief. And it keeps us from, the problem is called overproduction. We're not going to have to generate 10,000 images, only go to market on 1,000 of them, but only get 100 of good hits back, right? The hypothesis here is that we can just start at the 1,000 instead of the 10,000. How much does it save? This hasn't been in production long enough to actually say how much that actually is. But yeah, there's a question way in the back here.
So high level, we replace X number of people, and we need partners.
I don't look at this. The question is, are we replacing X number of people? I don't look at it like that. What we're doing is we're increasing our capacity in order to help more customers go forth. Yep, you're still going. That's actually what I hope for. The question is can the human at the end, help us tweak the AI and help us tweak the process, for the next round through and stuff like that. I actually want that to happen, right? I want those brilliant artists to give me the examples of why they think this is a terrible idea, even though the LLM says it's a great one, right? Because then I can start to augment my graph of thoughts to say, hey, you know what? Benji, one of our artists, doesn't like this, and we trust Benji, so don't do it. Don't do it this way, right? It's about a human in the loop, a man machine process going forward. I think this will have to be the last question. Then we're going to take a break and then go on to the final. Yes, Stephen.
26 cents and 30 seconds to generate the final image. How much would that be if you amortize the amount of effort that a human being spent trying to design the workflow into it?
Yeah, okay. So the question was, is if I amortize the amount of time it took for the humans to implement this workflow, how much would that drive up the 26 cents? This workflow, what?
A lot, right?
Yeah, but at scale, not so much, right? We do this 1,000 times and amortize it over and over and over. It just reduce it a lot, right? This was probably 80 hours of work all in for an engineer at, I don't know, $300 an hour, fully loaded. I don't know what you guys make. I don't care. And so we can calculate that out. And then for one image, yeah, this is it's way more expensive. But after we've saved 80 hours of work of an artist's work, then it's probably starting to, pay off a little bit. Okay, so let's take maybe 10 minutes for the next break, and then we'll get our final speaker up here, and we'll go from there. All right, thanks everybody.